Hi, I'm Kristen Grady, Marketing Director at NSR, and I'd like to introduce you to NSR's NCAT, our Non-GEO Constellations Analysis Toolkit. I will also walk you through a demonstration of how the NSR NCAT works. NCAT is an assembly of flexible and easy-to-use quantitative models that X-ray and benchmark non-GEO SATCOM constellations. Constellations, populated with thousands of satellites, are being deployed in both LEO and MEO orbits. These constellations, beaming tens of terabits per second, can transform our industry, making it vital for key decision makers to have the ability to visualize this impact at a granular level. NSR's NCAT provides this capability. NSR has developed 9 configurable tools utilizing data collected from 27 constellation shells, both granted and in-process FCC applications, in order to evaluate each HTS constellation. The NSR NCAT gives you the opportunity to add additional information from your internal database to evaluate each HTS constellation and simulate possible future modifications or other constellation initiatives. Now let's explore NCAT's Tool 4. Tool 4 calculates and graphs the number of satellites that are inside the visibility cone of a user terminal or gateway station across all latitudes based on orbital characteristics and the minimum antenna elevation angle defined by the operator. Rather than using probabilistic functions, NCAT Tool 4 utilizes a deterministic approach, which sweeps the entire longitude and latitude ranges to calculate the minimum, maximum, and average number of satellites in line of sight per geographic location. This process is somewhat CPU intensive, so NSR pre-ran the charts for all 27 constellation shells included. Users only need to run new simulations if changes are made to the input table, which is fully configurable. The calculation process may take a few minutes, depending on the PC or Mac and Excel version. As you can see, NSR has added individual Excel sheets with tool output tables and charts, one per constellation system. In cases where the constellation will comprise multiple shells, NSR provides satellite visibility charts and data tables for each shell and for the complete multi-shell constellation. Here's the example of O3b's equatorial MEO system, which can host 44 satellites. As we know, O3b currently has 20 satellites deployed, so fewer satellites are visible. O3b tends to use 15 degrees as the minimum elevation angle. To calculate this current scenario, we simply change the minimum antenna elevation and number of satellites in the input table. We select it in the Visualization tab and have it recalculated and displayed by the tool. May take a few minutes to converge, but it's that simple. The tool shows the new visibility chart and provides the output table used for the chart for users to leverage outside the tool itself, if needed. Note that if the minimum number of visible satellites results to be 0 for certain latitudes covered, this may not necessarily mean service interruptions, because the satellite operator may allow lower antenna elevation angles to assure continuous service and visibility. Also note that several constellation players plan to deploy multiple systems. Thus, sites could be served simultaneously by multiple sub-constellations with distinct orbital characteristics that assure a minimum of 1 satellite in visibility at all times. As you can see, the NSR Non-GEO Constellations Analysis Toolkit is easy to use and meant for both business and technical professionals alike. NSR uses it internally to holistically assess LEO and MEO HTS constellations in support of research studies and consulting projects. Thanks for watching, and please contact NSR if you're interested in learning more about the NSR NCAT.